Okay, let's talk about number 10, okay? So, well, we can do this one as we did in example number 9, okay? But in the previous slide, we talked about how we can like find this, the fundamental solution by the formula. We just derived the formula, right? And I'm going to show you how we can use that formula like for like this kind of linear, uh, the system of linear equation, okay? So let's do it, okay? The process is same, okay? We can start from eigenvalue. Then whenever you find eigenvalue, it will be complex number. That's what I said. Then like, but we don't have to worry about like, both of them because like they are complex conjugate and you're going to use only one of them. Then we will find the corresponding eigenvector. And also like, it doesn't matter like, like I'm not saying like it doesn't matter, okay? You don't have to find both of them because like the other one is always like complex conjugate form, okay? Then with that, we're going to plug them back into u1 and u2, which I showed you in the previous slide, okay? Then we can find the fundamental set of solution, okay? And then like linear combination of that one is the like your general solution, okay? So let me show you, okay? We will start from eigenvalue. Here we go. So to find eigenvalue, we're going to do the same thing. Determinant of a minus lambda I equals to 0. It is 1 minus lambda, 2, and negative 5, negative 1 minus lambda. Okay, I'm sorry, this is determinant, okay? Equal to 0. Then do the determinant, okay? 1 minus lambda and minus 1 minus lambda and plus 10 equals 0. To the distribution, it is minus 1 and plus lambda squared plus 10 equals 0. In order, lambda squared plus 9 equals 0, minus 9 on both sides, lambda squared equals to negative 9. Then finally, my lambda is plus and minus 3i, okay? As I told you, this is like complex conjugate, okay? So we are not going to take care like both of them, and one of them, like only one of them is fine, okay? So we're going to choose 3i, okay? Let me find corresponding eigenvector, okay? Okay, that's enough, okay? How can you find it? We're going to set up a minus lambda I v equal to 0, okay? Plug in everything. And then my vector is 1 minus, my matrix is 1 minus 3i, 2 minus 5 minus 1 minus 3i, and vector v will be written by v1, v2, and 0 vector will be written like this way, okay? Then from this guy, we can easily find 1 minus 3i v1, oh my goodness, this isn't v2, okay? Plus 2 v2 equal to 0. Is okay? So well, like as I did before, you can choose v1 as 1 or something like that, okay? But also like, and let me show you like another technique, okay? I'm gonna divide by, let me move like your v2 to the right hand side first, okay? Here we go. One minus 3i v1 equal to negative 2 v2, okay? Then let me divide by v2 on both sides and 1 minus 3i on both sides, okay? That this can be written as v1 over v2 equal to negative 2 over 1 minus 3i. This is the technique with a like a property problem in high school, okay? Then whenever you write like this way, then I can say your v1, you can set your v1 as equal to negative 2 and v2 as 1 minus 3i directly, okay? Then my conclusion is like this way. My eigenvector v is equal to negative 2 comma 1 minus 3i. Okay, so far there's no different with the like previous problem, okay? But what we're gonna do is we're gonna separate your real element and imaginary element, okay? Then we're gonna write as a plus bi form, okay? So this can be decomposed like this way. Negative 2, 1, and plus I, 0, and -3. Then I will say -2, 1 as vector A, and 0, -3 as vector B. And that's enough. Okay, now we can plug in this one into the formula in the previous slides. Okay, so let's say then, my U1 is equal to, well, like in my eigenvalue, there's no real part, okay, which means there's no exponential function part, okay? So we will write cosine and sine directly, okay? It is A times cosine 3t and minus B sine 3t, which is equal to minus 2 cosine 3t and cosine 3t minus plus, give me 1 second. Did I make a mistake here? Oh, it's fine, okay? So it is plus 3 sine 3t. Actually, like, this is like different with my note, but it doesn't matter, okay? They will be same, okay? And what about the other guy? U2 is A sine 2t, 3t, and plus B cosine 3t, right? Which is equal to minus 2 sine 3t and sine 3t minus 3 cosine 3t, okay? Then these, like, U1 and U2, as you talked about, we have to double check, like, with the Wronskian, but like we can skip that part, okay? And we know, like, if U1 and U2 form the fundamental set resolution, okay? Then my final solution is linear combination of these two, right? Which is equal to C1 times, can I write everything in here? Okay, let me write here. C1 times minus 2 cosine 3t cosine 3t plus 3 sine 3t plus C2 times -2 sine 3t sine 3t minus 3 cosine 3t. Okay, so let me double check. That's it. Is it okay? So this is the way to use the formula, like for the complex eigenvalue case, okay?